Hi everyone, welcome back to Math 2. This is lesson 6.7 and we are on activity 1, proving slope properties, Priya's proof. So here's Priya's method of proving that the slopes of two parallel lines are equal. Consider any two parallel lines that pass through the x-axis and the y-axis. So in this figure below, you can see that we've got these two parallel lines here. The second part of our proof says these lines form two right triangles with a second congruent angle, theta. So I'm just going to highlight these two right triangles so that you can see them clearly. So we've got one over here, and then we've got this one here in green. The tangent of theta will be equal for both triangles. Okay, so this is kind of going back to our trigonometry unit. So try to think about what the tangent ratio was. Number 4, therefore the parallel lines have the same slope. All right, so we're going to go through and answer a few of these questions to get a better understanding of this proof. So let's look at the first question. How do we know that the right triangles have a second congruent angle, theta? So we can see that they both have the right angles, right? And if you kind of turn the paper this way, we see that we've got these two parallel lines. And if you remember from the earlier parts of geometry, if two parallel lines are cut by a transversal, right? So we call a line that kind of cuts two parallel lines here a transversal. Then there are some angles that end up being congruent. So I want you to pause the video and try to think to yourself, like what does this theorem tell us about the angles that would be congruent here? All right, so when we have two parallel lines cut by a transversal, there are a pair of angles called alternate interior angles, which are congruent. And we can see here this angle and this angle are the alternate interior angles. They're just one set of alternate interior angles in this figure. So that is why we can say that theta, if we name this one theta, this angle over here will also be equal to theta because of that theorem, because these two are alternate interior angles. So I am going to write that here just into like a fully formed sentence. So if two parallel lines are cut by a transversal, alternate interior angles are congruent. And I'm going to put parentheses theta. So in this case, right, our alternate interior angle is theta in both of these cases. All right, let's look at question 2. So show and explain why the tangent of theta is equal for both triangles. So let's first step back and think about what the ratio of tangent means, right? So if you guys remember the SOHCAHTOA, right, I'll write like TOA here on the side. Our tangent ratio is the ratio of our opposite side length to our adjacent side length. Okay, so I am going to label these on our figure here. So in our blue triangle, from theta, this is my opposite side. Okay, and then we've got our adjacent here. And then in my green triangle, from theta, I've got this side here as my opposite, and then this side here as my adjacent. Okay, so we can actually connect this concept of the tangent ratio to unit 4, our similarity unit. So I'd like you to pause the video and try to answer question number 2 on your own and see if you can connect concepts of similarity with our tangent ratio. All right, so we have our right angle here and theta. And both of these triangles have the right angle that's congruent and theta that's congruent. So if you all remember, we went through a theorem in our similarity unit called angle-angle similarity, right? So if two triangles have two congruent angles, two sets of congruent angles, they are similar. So we've already got our right angles here and then theta. So the two triangles are similar because they have two sets of congruent angles. So then this will lead us to saying that because they are similar, corresponding side lengths are proportional, right? So because they are similar, the corresponding sides, they're going to have that scale factor. That is how we know that they are proportional and how they're related to each other. So because the corresponding sides are proportional, we then know that the ratios of the side lengths will be the same. Ratios of the side lengths So think of, right, if we were to try to find a scale factor here, the ratio of this opposite side to the corresponding opposite side, that's going to help us find our scale factor. And in this case, right, our tangent of theta is equal to opposite over adjacent. So when we think of our tangent ratio, right, it is just another ratio of side lengths. It is the ratio of the opposite to adjacent. So the tangent of theta in the blue triangle, right, is going to be the same as the tangent of theta in the green triangle. Their opposite over adjacent ratios will be the same because of the similarity relationship here, where their corresponding side lengths are proportional.